In this video, we're going to learn about a new kind of value called a Boolean and a new family of primitives called predicates. If we go to the course webpage and we go to the mechanisms page, we can see some of the values we've already learned about: numbers, like 1 and 3.5 and a half, and strings, like Marvelo, black, and carrot, and even images, like this square and this triangle. And we've also seen a number of primitive operations like plus and minus and times, and string append and string length, and operations on images like overlay and above and beside, as well as operations that make images like circle and square. Now we're going to turn to Booleans. Boolean values are used to represent the answer to true-false questions. As you might imagine, there are two of these values, and they're written like this. The true answer to a true-false question is written as true. This is the Boolean value true. And the false answer is written as false. Like other values, Boolean values are expressions. So if we were to evaluate this now, if we run this program, we'll see that the value true evaluates to true here, and the value false evaluates to false here. So true evaluates to true and false to false. The fancy term for this is that they are self-evaluating. Let's comment these out now. So if Boolean values represent the result of true-false questions, what are some of the questions? Well, before showing some examples of those questions, let's quickly define some useful variables that we'll be able to use in some of our other examples. Let's see. We're going to want to use some image examples. So we'll start by saying to Racket that we want to use the image primitives that we learned about before. Let's have a variable called x, the value of which will be 3. And let's have a variable called w, the value of which will be apple. And what I'm going to do here is I'm going to go ahead and run this. Even though nothing is really going to happen here now other than for these definitions to be processed, I want to get in a habit of running early and running often, so that if I do make some little mistakes, like perhaps I leave off a parenthesis or something, I'll catch those mistakes early. And let me go ahead and make two more definitions, a couple of images that'll be useful. So here's I1, which is a rectangle that's 10 by 20, and here's I2, and now I'll run that. Oh, and here's a good example of why it's useful to run often. I made a mistake here. Racket tells me that rectangle expects 4 arguments, but it found only 3. And if I go up and look at this, sure enough, I've only got one number there. I need 2 numbers. Let's make this rectangle be 20 wide and 10 high, whereas the other one is 10 high and 20 wide. I'll run that, and I'll also save it. It's good to run and save quite often. So now let's get to some of the questions that can produce true or false as an answer. There are many primitives that ask true-false questions. Here's just a couple of examples. I can say, is 4 greater than x? Well, let's see, x is 3, so is 4 greater than x? Yes, it is. And if we run that, sure enough, we see that this evaluates to true. True, 4 is greater than x. Let's try another one. Is x equal to 3? Well, yeah, x is 3, so this should also produce true. Let's run it and see. And yes, we still have the first true from is 4 greater than x, and we have a true from is x equal to 3. There's a whole bunch of these primitives that operate on numbers. For example, greater than or equal to 3 tells you whether the first number is greater than or equal to the second number. And of course, in that case, that's true. And as I say, there are many, many others. Okay, let me comment these out now so that they won't get in the way, so that the values down here won't get in the way of understanding what else we're doing. And I'll show you a new racket command here that's somewhat useful. If you select a part of your file, then you can go to racket, comment out with semicolons, and it'll comment all of that part of the file out with semicolons very quickly. Let me introduce a new term here. These functions that produce true or false are commonly called predicates. So we'll use that term going forward. So in addition to predicates operating on numbers, there are predicates that operate on strings. And not surprisingly, they have similar behaviors. So for example, there's a predicate called string equals ? that will tell you whether the value of W is equal to peach. And let's see, the value of W is apple. So we don't really think that apple equals peach. So this should probably produce false. And indeed it does. There's also a predicate similar to the less than predicate and greater than predicates we had here. We can say string less than ? apple pear. Now what does that mean? Well, it compares the strings in alphabetical order. So let's see, apple starts with A and pear starts with P. So apple comes before pear in alphabetical order. So this should produce true. And indeed it does. There's also primitives that operate on images. There's even a primitive that checks for the equality of images. Image equal ? I1, I2. Well, those are two different images. So that's going to produce this false. On the other hand, if you say image equal ? I1 to a different rectangle, it's also 10 by 20 and solid and red, that will produce true. In general, predicates, functions that produce true or false, are named with a name that ends in ? unless the name of the predicate is one of the short arithmetic symbols like greater than or equals or greater than or equal. So these don't have ? in their name, but all these others that are formed out of words and perhaps symbols do tend to end in ? That's just a naming convention that we follow. Let's comment these out and look at another important point about predicates. So I'll go to racket, comment out with semicolons. Now they're commented out. What I want to show now is that like other primitives, predicates can be combined to make more complex expressions. So for example, I could say, is the width of I1 less than the width of I2? So let's see, I1 has its width is 10, and I2 has its width is 20. So this should produce true. And indeed it does. There are many, many other predicates in BSL, just like there's other kinds of primitives. And you can use the help desk to discover them. One good way to do that is to look up the help for a related primitive you know exists, and then scroll around that part of the documentation looking for other primitives. So for example, if we know that equals exists, what we could do is we could say, well, I know that this will work, but I'm interested in finding out about other primitives. So what I'll do is I'll click on equal, say search in help desk for equal, and then I say equal provided from the HTTP beginner language. So I'll go look there, click on that, and sure enough, right next to equal, I see some other useful predicates like greater than, which compares numbers to produce a Boolean, or greater than or equal, and a whole bunch of primitives that operate on numbers are here. Here's less than or equal and less than. The key thing is you don't have to memorize the name of primitives. Okay? You'll end up learning the name of a number of primitives that you use often, but you'll always be able to look up primitives in the help desk if you need to. There's a special category of predicates called type predicates that we will start to need in week 2, so let's take a quick look at them right now. What a type predicate does is to produce true if its argument is a specific type of value. So here's a couple examples. If I say number question mark 1, let me go ahead and comment this out as well as this out so it won't get in the results won't get in our way. If I say number question mark 1, that means is 1 a number? And 1 is a number, so that's going to produce true. And if I say number question mark 2.4, that will also produce true. But if I say number question mark Gellert, that is not a number, so that's going to produce false. And sure enough, I've got true and true for the first two and false for the third one. And there's lots of other type predicates. There's one for images, for example. So image of 1 is false, and image of I1 should be true. Let's run that. So we've got the first three, true, true, false, false, and true. And so on. Let's comment that out now. Okay, so we've seen Boolean values and predicates as well as type predicates that produce Boolean values as their answer. These predicates ask yes or no questions. Before going on, it's important to be sure that you are comfortable working with Booleans and predicates. So here's a problem for you to do. And what I suggest you do is look at this problem, then stop the video and solve the problem yourself in the space below the problem. Go ahead and solve the problem in this space here. And once you've solved it completely yourself, start the video again and we'll walk through the answer together. By now you should have solved the problem given here. So what I'm going to do in the video is walk through my development of the answer so you can compare that to your work. So let's see. We remember that we have the images I1 and I2, and we're supposed to write an expression that produces true if the area of I1 is greater than the area of I2. And we're reminded that the area of an image is just its width times its height. So what I'm going to do here is, rather than trying to write this whole thing in one go, I'm going to write some pieces of it. So first, let's see what's the area of I1. Well, that's just the product of the width of I1 and the height of I1. That's the area of I. Oops, there's an H there. That's not going to be right. The width of I1 times the height of I1. And I'm going to go ahead and run this right now. Make sure there's no mistakes in it. So that's the area of I1. And here's going to be the area of I2. And I'll run that to make sure there's no mistakes in there. And now I just need to produce true if the area of I1 is greater than the area of I2. So I'll just take what I've got here and I'll put open paren greater than around it. Now if I go down to this line and press tab key, the tab key is what I pressed here, Dr. Racket will line my parens up nicely. I'll close that paren and run that, and that produces false because the area of the two rectangles is the same. They're both 10 by 20. One is 10 by 20 and the other is 20 by 10. So they both have area 200, and so the area of I1 is not greater than the area of I2. Okay, that's the end of our video on Boolean values and predicates.